If you run apps or services on Red Hat Enterprise Linux and face tricky issues that are hard to pin down, this is the place for real solutions. I'm Prince. I have spent over 15 years building and managing enterprise infrastructure, container orchestration, security, and automation, mostly on Red Hat Enterprise technology stack. Here, I share proven fixes to real problems from actual production environments. No fluff, no theory, just actionable steps that work. The topic we will tackle in this video is how to debug recurring RPM database corruption in AlmaLinux that uses SQLite Backend for RPM database. Improper handling of abrupt terminations, file system errors, or concurrency conflicts by SQLite can directly lead to database corruption. These vulnerabilities arise when SQLite fails to manage transaction rollbacks, locking mechanisms, or disk input-output errors effectively. Disk I/O issues, high disk latency, partial writes, or storage hardware failures can corrupt the RPM database during read-write operations. Third-party tools, interference from external tools like Microsoft Defender for Endpoint, may forcibly terminate processes, disrupting SQLite transactions. Journaling misconfiguration, using Pragma journal mode if off, disables SQLite's rollback journaling, increasing corruption risks. Safer alternatives include wall or delete modes. Backup is a crucial step to debugging. Before any file removal or database rebuild, it is highly recommended to back up your data, as issues during the rebuilding process could potentially worsen existing corruption. Here are the vital debugging steps. Step 1. Eliminate stale lock files and active processes. First, you will want to kill processes accessing var lib RPM. Second, verify that no processes are accessing var lib RPM. Third, you will need to remove stale lock files. Step 2. Validate SQLite database integrity. First, you will need to check SQLite for database consistency. Second, if corruption is found, repair the SQLite database. Third, after SQLite repairs, validate RPM functionality. Step 3 is to monitor disk input-output and file system health. First, check the disk input-output during RPM operations. Run RPM-QA in another terminal. If disk utilization is greater than 90%, or a wait is greater than 10 milliseconds, focus on addressing disk input-output issues. Check the disk health with the commands as shown on the screen. Verify file system health using the file system check command as shown on the screen. Step 4 is to audit SQLite journaling and concurrency by following the instructions as seen on the screen. Here are some of the ways to limit concurrent access to the RPMDB. Step 5. Debug with system trace and system logs. 1. Trace system calls during RPM operations. 2. Review kernel logs for input-output errors. 3. Check system D journal logs. 4. Use audit D for system call monitoring. This identifies processes attempting to access the RPM database, including denied operations. Here is a valuable troubleshooting checklist, which includes a step-by-step verification process. Step 1 is to kill conflicting processes. Step 2 is to perform SQLite integrity check. Step 3. Check the disk health. Step 4. Check SQLite journaling mode. Step 5. Review the logs. By addressing SQLite-specific factors such as journaling, concurrency, and validating disk and file system health, you can stabilize the RPM database and prevent recurrence. If all standard debugging steps and advanced diagnostics fail to identify the root cause of recurring RPM database corruption, escalate to AlmaLinux support after exhausting the checklist. Thank you for following along and watching this video. If this video helped you fix the issue, please hit the like button and share this video with your team. If you work with Enterprise Linux, consider subscribing for more real-world solutions.